A robot may steal a job from the person who trained it. In a small textile town, workers stitch, fold, iron, and clean, while cameras sit on their foreheads. Some wear GoPros. Others wear smart glasses. Their hands become lessons. Their kitchens become classrooms. Their laundry becomes robot training data. For 3 hours of recorded housework, one woman earns 1,000 rupees. At one factory, 60 of 200 workers spend 6 to 8 hours a day generating robotics data for an extra 10,000 rupees a month. This looks like work. It may be the rehearsal for replacement, because the new AI economy does not only need coders, chips, and billion-dollar labs. It needs millions of ordinary human movements, captured from eye level until machines can copy them without asking who taught them. AI is sold as magic, but behind the magic is a brutal machine. Around $1.5 trillion is being poured into large language models, mostly to keep them learning, scaling, and consuming more data. That money changes everything. One expert calls AI a marketing term because it unlocks capital faster than almost any technology before it. Another warns that AI concentrates power by design. The more data, compute, and talent a company controls, the harder it becomes for anyone else to compete. That is the structure. And yet, one massive technology services economy believes it has a path. It claims to hold perhaps the world's second largest AI workforce. Its population is 1.5 billion. Its advantage is not chips, it is people. But is that power or dependence? In Karur, a small town in Tamil Nadu, there are not many high-paying technology jobs. But inside one textile factory, the future of robotics is being stitched into the present. The factory floor has stations. At one table, workers sew. At another, they fold. Elsewhere, they iron, arrange, and repeat movements that look simple only because humans learned them years ago. On some foreheads are cameras, recording from the worker's own viewpoint. That view matters. Robots do not just need to know what a cup is. They need to understand how a hand reaches for it, how fingers grip it, how fabric bends, and how a room changes when someone cleans it. A lab in San Francisco cannot easily capture every ordinary motion in every ordinary home. So the work travels elsewhere. A company called Objectways began in 2019 as a data annotation business. It later moved into robotics data, egocentric video, gripper data, teleoperation data, and other streams needed to train machines. Egocentric data means human life from the human point of view. Kitchens, bedrooms, living rooms, bathrooms, cleaning, folding, sorting, reaching, turning. Every small act becomes a building block for robots. The target scale is shocking. Clients may ask for 6 months of volume to be produced in a single day. One expectation mentioned is 500 million hours of data in one day. Think about that. That number is not just a production target. It is a signal of how hungry the AI race has become. The machine does not need one example of folding clothes. It needs endless variations, endless bodies, endless homes, and endless repetition. And the person wearing the camera may never see the final machine. The question is not whether robots can learn. The question is who gets paid when they do. Darni is 28 years old and trained as a teacher. After her baby was born, continuing that job became difficult. Then, this new work arrived. She wears a camera and records daily tasks at home. She folds clothes. She cleans shelves. She tidies toys. She washes vessels. She records ordinary life for 6 to 7 hours, even though the pay rate mentioned is 1,000 rupees for 3 hours. For now, she believes her role is safe. The robots still need training. Until the model learns enough, humans remain necessary. That is the trap. The first wave of AI labor often looks like opportunity. It reaches places traditional tech companies ignored. It lets people earn without leaving home. It creates paid work in towns where formal jobs are scarce. But the work may also build the system that lowers future demand for workers. If automation handles 60% of a process, a company that once needed 100 people may need only 40. That math is merciless. Data work raises an uncomfortable question. Is this a fair exchange because someone accepts the price, or is it extraction because the value flows upward? The supply chain is built to capture human knowledge cheaply. A person records the movement. A contractor processes it. A platform trains the model. A robotics company sells the capability. The biggest profit usually lands far from the person wearing the camera. And the risk is not only wage pressure. In some workplaces, cameras could become surveillance tools. Workers may be told to wear them without extra pay. The same recordings that teach robots could monitor speed, mistakes, breaks, and discipline. So the human becomes both trainer and target. This is not new in AI. Large language models already sparked fierce debates about whose writing, art, code, and knowledge created systems now worth billions. Robotics adds bodies to that debate. When your movement becomes data, who owns the skill? Long before robots needed laundry videos, the same economy built a huge data annotation industry. Annotation is the hidden labor of teaching computers what they are seeing, hearing, or reading. A self-driving car does not magically recognize a street. Someone labels the truck. Someone marks the car. Someone outlines the billboard. Someone corrects the algorithm when it is wrong. The machine learns because people repeat. This industry goes back roughly 15 years. One workforce company noticed a powerful pattern. About 60% of engineering colleges were concentrated in small towns, which meant roughly 60% of graduates came from those places too. Many were first-generation graduates. Their parents were farmers, wage workers, tailors, clerks, police staff, and small earners. Families often borrowed money for education, but major IT and business process companies rarely recruited in those towns, so the work moved to them. For women, the impact could be profound. In socially conservative communities, paid local technology work can change family power. One woman became the first graduate in her family, after relatives argued that money should not be spent on her education. Her mother had married at 16 and pushed her daughter toward independence. Now she helps support her parents and pays for her children's health and schooling. Her son is 7, her daughter is 5. Her salary becomes a shield against dependence. That is real value. But the work itself can be demanding. Annotation is often like an assembly line. Accuracy must be repeated thousands of times. A tiny error in a label can weaken a model. Human feedback, video annotation, audio annotation, multi-turn conversations, and reinforcement learning all require discipline. This is the invisible factory under AI. But can a country become powerful by supplying the labor that trains other people's machines? Its services exports are enormous, around $330 billion to $340 billion. That is larger than any single goods export category in the country. The technology services boom began in the early 1990s and grew around global outsourcing. English skills helped. Engineering talent helped. Lower costs helped more. If a job cost $1 elsewhere, it could sometimes be delivered for 20 cents. For 25 years, that model worked. Now AI threatens its foundation. High-volume, repetitive, white-collar tasks are exactly where AI substitution can hit first. HR processes, accounting workflows, coding support, software maintenance, and customer operations are all exposed. The backroom is being automated. Some leaders argue the sector will adapt. New AI jobs will replace old ones. The total number of tech jobs may even rise if the workforce becomes the world's AI training base. Others see danger. The old services giants were profitable, but many did not lead the AI revolution. Private sector research and development lagged. The biggest AI infrastructure races are dominated by Western firms in China, where capital, chips, and hardware ecosystems are deeper. In the first 3 or 4 months of one recent year, about $25 billion reportedly left local markets. Some capital moved toward Taiwan and South Korea, where chips and AI-related hardware play a clearer role in the global race. Money follows the bottleneck. Still, the services model is not dead. It is mutating. Global capability centers now perform advanced work inside the country for foreign corporations.
Tesco, a £66 billion business, offers one example.
From Bengaluru, teams support architectural design, civil engineering, mechanical engineering, and electrical engineering. They help manage more than 100,000 fridges across 4,500 stores through an IoT platform. They also use decades of customer data. Tesco has around 30 years of information on about 22 million customers.
AI studies patterns and helps personalize shopping.
A supplier wanted to raise bread prices by 10%. The AI cost model broke bread into ingredients: yeast, water, flour, and other components. It then tracked what was inflating and what was not. Even store problems can be routed automatically. An AI system can detect an issue, classify it into one of 300 possible store problems, and send the right vendor without human handling. That is not basic outsourcing anymore. It is a glimpse of the better path. Local teams using AI to move up the value chain, not just feeding raw data into someone else's machine. But the other path is already here too. It is the path where people label, record, correct, and demonstrate for systems they do not own. It is the path where the most ordinary parts of life become training material. It is the path where a worker's hand movement may become a robot's future product feature. The contradiction is sharp. The same AI economy can create dignity and dependence at the same time. It can bring paid work to small towns and still move the largest profits somewhere else. It can give women new income and still expose them to systems that may replace the very labor they perform. It can turn a country into a global AI workforce while leaving the most valuable models, chips, platforms, and contracts under foreign control. Scale is not the same as power. The future may split in two directions. In one version, this economy becomes a use case capital for AI, massive adoption, millions trained, real productivity gains, and new work created across retail, health, logistics, finance, and manufacturing. In the darker version, it becomes a human data mine. People label the world, people record their homes, people correct the model, people demonstrate the task. Then the machine learns, the platform scales, and the worker becomes cheaper than the skill they gave away. That choice matters. A young workforce can adapt fast. A government ambition points toward developed country status by 2047. The talent pool is huge, and few places can match that scale. But talent without good jobs loses value. Data without ownership becomes dependency. Adoption without bargaining power becomes surrender. The AI factory is already running. The question is not whether humans will train the machines. The question is whether they will own any part of what those machines become. Because the most dangerous future is not robots replacing workers. It is workers building their replacements for wages too small to buy back their own future.